Man should return to his source, and this source is in his divine origin, whether we like it or not. We got used to subscribing to Darwin's theory, but the thing is, it's only a theory. That's why it's called Darwin's theory of evolution, while the divine origin of the world is a reality. Today, more and more physicists and other scientists are talking about the creation of the universe and everything in it. And this does mean creation, as opposed to some sort of random emerging into being out of nowhere. Ever since man arrived in this divine world, he has used it and consumed it for his pleasures and whims at the cost of polluting and destroying everything around him. The trouble is that mankind remains blind to the fact that all illnesses, pandemics, and human suffering is nothing but divine retribution for what we're doing. Whenever God sends a disease into our world, He always supplies a remedy. We only need to discover it. Robert Freitas, an American scientist and founder of the nanomedicine theory, defines nanomedicine as a science as well as a technique that can be used to detect, treat and prevent various illnesses and traumas by application of molecular technical agents and instruments based on scientific knowledge of the human body's molecular structure. Surgeons have advanced from stitching and amputating to repairing hearts and reattaching limbs. Using fine tools, they join delicate blood vessels and nerves. Yet even the best microsurgeon can't cut and stitch finer tissue structures. Modern scalpels and sutures are too coarse for repairing capillaries, cells and molecules. Consider delicate surgery from a cell's perspective. A huge blade sweeps down, chopping past and through the molecular machinery of a crowd of cells, slaughtering thousands. Later, a great obelisk plunges through the crowd, dragging a cable as wide as a freight train behind it to rope the crowd together again. Only the ability of cells to abandon their dead, regroup and multiply makes healing possible. Drug therapy, unlike surgery, deals with the finest structures in cells, and drug molecules are simple molecular devices. Many affect specific molecules in cells, but drug molecules work without direction. Once dumped into the body, they tumble and bump around, haphazardly, until they bump a target molecule, fit and stick, affecting its function. Though drug molecules affect the tissues on a molecular level, they are too primitive to feel, plan and function independently. And so Eric Drexler arrives at the conclusion that nanosystems created by man for medical purposes must have an unsurpassable advantage over any other medical technology. However, his passion for this rationale makes his argument somewhat one-sided. Drexler's convinced that the drugs of the future should be able to feel, strategize, and function as intelligent agents. His forecast is that such drugs and technologies will enter the market in about 30 to 40 years. Imagine his surprise when he finds out that such drugs have been around for quite a while. They were developed in the USSR 30 years ago. Since the mid-20th century, science has been developing knowledge in structural biology, biochemistry, electronics, and studies of structure and composition of materials. At first, breakthroughs were made in one-time lab experiments, but in time, the results became commonly achievable, and thus, we finally learned to study matter at a nano level. Nano is derived from the Greek word nanos, meaning to dwarf, and denotes 1/billionth part of a whole. The term nanotechnology refers to technologies operating with objects the size of 1/billionth of a meter, the so-called nanometer, which approximately equals the measure across 6 carbon atoms. Similarly, terms nanomachine, nanorobot, and nanocomputer refer to complex technical objects produced as a result of operations with substances at the molecular level. We are now in the Nuclear Magnetic Resonance Laboratory of the Moscow Institute of Bioorganic Chemistry. The device you see is a superpower microscope that allows us to see objects the size of an atom. It's as powerful as the Hubble telescope, and it's designed to look at the infinitely small. It gives us a glimpse of the universe the way it was billions of years ago, so that we can admire its infinite beauty. With its help, we can get an atom-precise view of everything within our own bodies. First of all, I'd like to say that what's going on with nano projects now reminds me of the nuclear and space projects that the Soviet Union ran in the 1940s and 50s. One difference, however, is that back in those times, there were landmark events, such as the launch of the first Sputnik, or man's first flight into space, or the first nuclear bomb explosion. And as soon as they were announced, the whole planet immediately knew that a breakthrough had been made. But I don't think anything like that is possible with a nano project. The scope of nanotechnology is so vast that there cannot be any single major breakthrough. And the range of its application will also be unprecedented.
You have a grandstand seat here to one of the most momentous events in the history of science.
In the mid-20th century, mankind did not merely accomplish a major breakthrough, he trampled on the most essential of all bans, "Thou shalt not kill," this time on a global scale, and found himself facing a new reality. That new reality included a direct road to the potential and complete extermination of man as a species. Man went far beyond self-preservation instincts. Lured by the temptation to seize the ultimate military advantage, he developed thermonuclear weapons, something never seen before. In the 1960s, the people of the USSR, the same people who defeated Hitler and saved the world from the Nazis at the cost of millions of its citizens' lives, faced again a stark choice: to be or not to be. At the time, the USA was actively developing its nuclear program. US naval and military bases and those of its allies were deployed in dangerous proximity to the USSR's borders. It gave the USA a major strategic advantage, the capacity for multiple strikes, which could kill millions of people in major Russian cities, terrify those who survived, and strip the country of communications, power supplies, medical help, and centralized control. The American army was the only one in the world to have tested nuclear weapons in action, and the US seemed to be quite comfortable with this fact. The only way to hold back the Americans was to develop a capacity for a counterattack which would be just as powerful. Only the prospect of a fatal blow hitting American soil was an argument convincing enough for presidents and generals. However, our country's geographical location wasn't helping this plan. US territory, including its strategic targets, was practically out of the Soviet Army's reach. That's why the USSR made it a top priority to develop a strategic nuclear submarine force, which was subsequently deployed in the vicinity of the US coastline. Successful underwater missile launch tests let the world know that there would be no easy military solution against the USSR. It would have been impossible to destroy all Soviet submarines, while a single counterattack from the depths of the ocean would have been enough to visit serious destruction on US soil, should it choose to launch the first strike. Ever since then, Russian nuclear submarines have been on permanent duty, protecting our country. These changes, however, brought about new challenges to the military medical service. The high level of responsibility combined with the unparalleled difficulty of military duty on nuclear submarines resulted in such serious impairment to submariners' health that it began to jeopardize the efficiency of the entire strategic shield of our country. Submarine crews had to stay on duty for many months. They had to deal with frequent malfunctions of the nuclear power units. These submarines were new and had not been fully tested at the time. All this was causing severe health problems with the submariners. The Russian Navy's medical service had to address a new condition which was termed premature aging effect. This effect had also been noted in other military branches, such as supersonic jet pilots in the Air Force or silo staff in the Missile Defense Force. All of these cases shared the same symptoms: severe impairment of the following systems, which are critical to life: immune system, endocrine system, nervous system, cardiovascular system, reproductive system, vision. The Army Command Headquarters ordered the medical force to find a solution that would lead to the complete recovery of the affected personnel. In other words, they had to find a way to reverse premature aging. Clinical studies revealed that the key to the whole process was a disturbance in metabolism. Cells of various tissues would lose their vitality. First, they would become dormant. Second, they would stop reproducing, and then finally die. Metabolism. Metabolism is a set of ongoing chemical reactions that happen in living organisms to maintain their life. Metabolism uses energy to construct components of cells such as proteins and nucleic acids. Metabolism is the fundamental mechanism sustaining vital functions in humans and all other living organisms. The organs in young men's bodies would grow old and weak, and the usual treatment approach, the prescribed resting, a special diet, and conventional therapies was not helping. It looked as if a malevolent sci-fi time machine clock was working inside the soldiers' bodies, killing off tissue cells at a much faster rate than usual. This discovery gave the researchers insight into the nature of the problem. The task was shared, but only the Army medical staff were aware of the ultimate goal of the research. It was a highly classified project. That year, Vyacheslav Morozov and myself were in our final year of studies at the Leningrad Military Medical Academy. By that time, we had already been researching the problems of recovery of vital bodily functions impaired by radiation, traumas, and intoxication for 3 years. And in all these cases, the adverse impact basically came down to suppressed protein synthesis. So the question was, how could we recover the synthesis? We decided to use a physiological approach. We studied the organs and processes which are impaired first and most severely, such as the immune system, brain, liver, heart, and the reproductive system in young calves and pigs. We were able to identify and produce agents which helped improve the impaired functions of these organs when introduced via an injection. The important thing here was that the agent obtained from the immune system turned out to help restore the immune system function. The agent recovered from the brain improved the brain function, and the heart agents facilitated the heart recovery. In other words, we discovered tissue-specific regulation processes that yielded a reliable and positive effect. Students talk about Morozov and Khavinson walking the corridors of the Oncology Institute, asking for someone who would be willing to research the pineal gland. I was an educated chap, and I knew that it was a very significant gland, and so I volunteered. The St. Petersburg Oncology Institute's research laboratory was the oldest experimental lab in the USSR. It was engaged in an anti-cancer research program. Here, in the Institute's animal test facility, we started researching tissues extracted from immune and endocrine systems glands. The thymus is a gland of the immune system. Just like bone marrow, it plays an essential role in the function of the immune system that protects the body on all levels. The thymus is located behind the breastbone. It is the first organ of the immune system that develops in a fetus. Pineal body is a small endocrine gland located near the center of the brain between the two hemispheres. It produces the serotonin derivative melatonin. Melatonin regulates the function of the endocrine system, modulation of wake-sleep patterns, seasonal behavior in many animals, blood pressure, function of brain cells, and function of the gastrointestinal tract. The pineal gland's key function is to regulate daily biorhythms, so one could say that it is responsible for the body's inner biological clock. This clock's malfunction results in a rapid deterioration of health. We incited premature aging in test animals and proceeded to administer the obtained agents to one group of subjects and monitor them against the control group. Upon completion of the treatment course, we compared cell samples obtained from the two groups. This research method allowed us to run a thorough and comprehensive study of any agent. We produced a preparation out of the substances extracted from the thymus. Its patent name is Thymolene. It's been on our country's pharmaceutical market for over 20 years now. It's available over the counter at any drugstore. It was the world's first developed immune system preparation. Later on, further research of this drug revealed that its active agents are peptides. Peptides and proteins. A human body consists of 100 trillion cells, and each of these cells is comprised of hundreds of millions of protein molecules. Proteins can be said to be the construction material of our bodies. They also function as true nanomachines. Each of the hundreds of thousands of various proteins is distinguished by a unique structure, and every single protein has a specific task it performs within the body. We can distinguish between proteins of bones and muscular tissues and those of skin and our brains. Specific proteins called enzymes and hormones control functioning of all body systems. Large protein molecules consist of peptides. We made two principal discoveries. The first one was that peptides extracted from the pineal gland inhibit tumor development. We ran a comparison test against melatonin, which was known to be able to inhibit breast cancer development in mice by 54%. Our preparation, which we called epitelon, yielded a result of 80 to 90%. In addition, we ran another test on menopausal rats to see if the agent could recover their reproductive function. The results were shocking. The aging rats went back to a normal menstrual cycle, and when we put young male rats into their cage, they produced a healthy litter. This report was published by the Academy of Sciences, and we received an award in recognition of this discovery. Back then, these young researchers had no idea that the conclusions they arrived at would lay the groundwork for a whole new branch of scientific research. In 1971, after we had produced those preparations, my friend and I were transferred to serve in the Trans-Baikal military district. We graduated from the Military Medical Academy with the rank of lieutenants and were eligible for military duty. We received an award from the Military Medical Academy. We had thought that admission to a postgraduate program would surely be ours, but we were ordered to serve in the army first. The scope of the military duty assigned to the young lieutenants included further scientific research. However, the problem was that this was barely understood by their direct superiors. At some point, rumors reached my ears. People were saying, "Look, they're good fellows, but they're so much into science and research, while we're doing completely different things here. We're on military duty. Please take them back." And so I called them back to Leningrad, to my research lab. However, we never made it back to the academy. We got stuck in a medical battalion in the Leningrad region. That was it. We had to figure out what to do in this situation. We looked round and found a way to continue our research at the Petrov Oncology Institute. That's where we completed our PhD while serving in the medical battalion.